Firstly, we'll look at and probabilities. So this is, for example, if I said, what is the probability that I draw a 2 and a 3 in my first hand? So I'm talking about the probability of a 2 and a 3. Well, I can look at this two ways. Originally, I can say, well, I've got a 2 and a 3. So how many ways can I get 2 and a 3 if I draw two cards? Well, looking at this, these are the only two cards that I'll take. So I can either have a 2 first and then a 3, or I can have a 3 and then a 2. So I've got 2, 3, and 3, 2 as my options. These are the possible combinations that are good. So when I talk about a probability, it's always how many options on the bottom versus how many are the outcome I want. So I'm going to have a 2 on the top. Now I need to think about how many combinations can I have with 4 numbers. So if we just write them all out, start with I get a 2, I can have 2, 3, 2, 4, 2, 5. If I drew a 3 first card, I can have 3, 2, 3, 4, and 3, 5. If I drew the 4, I would have 4, 2, 4, 3, 4, 5. And lastly, if I drew the 5, I would have 5, 2, 5, 3, and 5, 4. So these are all the possible combinations. So you can see here, I've got 3, 6, 9, 12. So there's 12 possible combinations. 2 of them are the one I want. So I can simplify this to 1 over 6. So the probability out of 4 cards that I get a 2 and a 3 is 1 in 6. I can do this a slightly different way as well. Even though I say I'm going to draw 2 cards at the same time, if I picture that I draw one card momentarily before the other, I can think about it of drawing this card and then drawing this card rather than pulling 2 at the same time. So from before, if I just drew the 2, what is the probability that I get that 2 out of the 4 cards? Well, there's 1 out of 4. Now if my next card was 3, what is the probability that I get the 3? I've taken this card out, so now it's not replaced. So there's only a 1 in 3 chance that I get that 3 as my next card. In probabilities, when I have something like a 2 and a 3, that's the same as saying what is the probability of 2 times by what is the probability of 3. So now if I've got, this was the 2 and this was the 3, I need to multiply them, and this is going to give me 1 over 12. But notice before I didn't have 1 on 12 when I calculated it. Before I actually had 1 on 6, but I'm forgetting something. So what I've done is I've said what's the probability of a 2 and then a 3, and I've done them separately and multiplied them together. But equivalently, I could say, well, what about the probability of 3 and then a 2? Well, that's probability of 3 times probability of 2, which is 1 over 4 times 1 over 3. So that gives me also 1 over 12. So I can take this gives me what I want, but this also gives me what I want. So I could choose this, and I could choose this. So if I've got 2 combinations, I just add them together. So this becomes 1 over 12 plus 1 over 12, which gives you 2 over 12, or I can simplify that to 1 over 6, as I saw before. So in shorthand, if I wanted the probability of a 2 and a 3, I say, well, that's the same as the probability of a 2 multiplied by the probability of the 3. Now remember that this is also the same as the probability of a 3 and a 2, so I have 2 lots of that, 2 options. This was equal to, if I drew the 2, it's a 1 in 4 times by, now I've taken a card away. Remember, there are no longer 4 cards, even if I take them at the same time, really I've taken one already with the 2. So now I've got a 1 in 3. So this gives me my 1 in 12. And on the other side, I also have the other option where I have the probability of the 3 and 2. And this gives me exactly the same thing where I get 1 on 12. So I add the two together. And the reason that we add them here, I'll show you in just a minute. This is part of the OR probability. If we look at an OR probability, this means what is the probability that I get a 2 or I get a 3? Well, I can write this the same as the probability of a 2 plus the probability of a 3. And now it becomes plus. Whereas if it's an AND, it's a times. If it's a plus, it's an OR. So if I write this, AND equals times, OR equals plus. So the reason this is because what is the probability that I get a 2? Well, it's a 1 in 4. But what is the probability that I could get a 3? Well, that's a 1 in 4 as well. So, but either of those is fine. So if I think about how many ways can I get what I want, well, I can have a 2 or I can have a 3. So there's two options. How many cards are there? There's 4. So you can see that if I did this, probability of 2 and probability of 3, and I want 2 and 4, then I have to just add them, and that gives me the 2 and 4. So this process, the reason we add is because it's the same as saying, well, now I don't just have one option to satisfy my probability. I've actually got 2, this one or this one, and there's still 4 cards. So I get a 2 in 4. And mathematically, I can find that using this formula, where the probability of a 2 or a 3 is the same as probability of 2 plus 3.